All right, I've given you a little bit of a head start. Question number 1, given the terminal side, which just means, you know, the end side. Let me change my color up here. This pink color is good, I guess. Let's do a real pink color. How's that? Ultraviolet. Cool. Goes through 3, -2. That would be 3, -2. It's in that 4th quadrant. Sketch the triangle and determine the value of r. We talked yesterday. R is like the radius, which is the hypotenuse. So find the value of r. Okay, so we need to do a little Pythagorean theorem. 3 squared plus 2 squared equals r squared, and 3 squared is 9, and 2 squared is 4. And so that's looking like 9 plus 4 is 13. Square root both sides. R is equal to the square root of 13. I think we did this triangle before, actually, when we were talking about the homework. Okay? So R represents the blank of the circle. Everybody remember what that is?
No, the radius.
The radius, right, the radius of the circle. If we take this R and we spin a big circle, it's gonna make a circle. And that R, or the hypotenuse, is gonna be nice, what our value is. And then what is the sine, cosine, tangent? I don't like it when they write them side to side. I like to write my sine, cosine, tangent, ups and downs, but whatever. We're down here in this 4th quadrant. A smart trig class, only cosine is gonna be positive down there. So sine and cosecant are gonna be negative. Cosine positive with secant, tangent negative, cotangent negative. Our sine is gonna be opposite over hypotenuse, which is gonna be 2 over square root 13. So I'll put that square root 13 back in the top. Cosecant is gonna be upside down, square root 13 over 2. Cosine is gonna be adjacent over hypotenuse, 3 square root 13 over 13, and then square root 13 over 3. And then tangent's gonna be 2 over opposite over adjacent, 2 over 3, and then 3 over 2. Again, all review, a nice question that asks us lots of things that we've learned so far. Here's where we're going to talk about, we haven't really done any like weird questions so far. Like we've definitely done some that might not feel super comfortable, but we haven't done any of those trick questions yet. I give you 2 sides, cool. You do the Pythagorean theorem, cool. Maybe it's annoying, but it's never a trick. And so here on the notes today, so what if the terminal side of theta passes through 0, 5? Obviously, what's different about this question?
It has to pass through a certain.
Right, and so did the last one, which was 3, -2. But this coordinate is a 0. So first of all, I know we've already done algebra 1, geometry, algebra 2, but where is 0, 5? Does 0, 5 mean right 5 or left 5 or up 5 or down 5? Right, this would be up 5. So that is our coordinate to make a triangle, but it's not really working very well, right? Our triangle, which we like to say always has one corner at the origin, and we draw a triangle like this, nice, it's a nice triangle. For this question, if I try to draw a triangle, it doesn't really look anything like a triangle. We talked about how the x is always considered to be the adjacent side, and the y is always considered to be the opposite side. So if this is a triangle where the opposite side is 5 and the adjacent side is 0, it's not a very good triangle, because we should slide this bottom until it's 0. The triangle pretty much goes away when we try to do that. So this is definitely a trick question. Definitely something different, okay? Oh goodness, it said it did not like that, by the way, making our triangle 0. Okay, we're good. Determine the value of r. Well, we're always, right, we're always doing this. We just don't really have a triangle. We just kind of have a line for this question. Determine the value of r. What if we were going to take this as 0, 5, spin it around in a circle, what would be the radius of this circle? It's only given us 2 numbers for the whole question. It's giving us a 0 and a 5. Is the radius going to be 0? No, the radius is going to be 5. How far is it from the origin up to here? It's 5. So the radius is going to be 5, or the value of r is going to be 5. Now, what is the value of theta? Well, if we draw our triangle like this, again, that theta, I don't know that I can really grab it that well since it's on a piece of paper. Our triangle is kind of busted. But if we think of it like this, here's where we are, here's where we normally start, and how far around the circle did we go? Did we go 50 degrees around the circle? Did we go 180 degrees around the circle? We've gone 90 degrees here. So our value of theta, we're going to go with 90. Okay, strange, 90 degrees. Okay, then what is sine, cosine, tangent, cosecant, secant, and cotangent? Again, we have a very weird triangle here because our triangle has the bottom side of 0, which shouldn't really work. It has the 5 as the opposite side, and we determined also 5 as the hypotenuse because the triangle is so squished thin that the opposite and the hypotenuse are the same. So let's make welcome back. Let's figure out our little fractions here. So sine of theta, which is supposed to be opposite over hypotenuse. What are those 2 numbers? Opposite 5 and hypotenuse 5. And what is 5 over 5? 1. So definitely something a little new here. The sine of theta is equal to 1. Okay, what about the cosine of theta? Adjacent hypotenuse, 0, 5. And what is 0 divided by 5? 0. It's weird, but because, again, it's like if we draw a triangle here, and 0 is our x number, because we need to go 0 in the x direction, and 5 is the opposite. That means it's a line that goes straight up and down. And what is the hypotenuse? What is the radius of that? What is the length of that line? It's, yeah, it would basically be 0 squared plus 5 squared equals x squared. 0 squared is 0. 25 equals x squared. Square root 25 is 5. So you would get 5. Okay, so let's do the tangent. Tangent is opposite over adjacent. What's the opposite number?
5.
And what's the adjacent number?
0.
And what happens if you divide anything by 0? So remember, dividing by 0 is the worst thing you can ever do when it comes to math. We hate dividing by 0. Even when I teach calculus in first period, you don't divide by 0. We don't like dividing by 0. If you remember algebra 2, it's been a long time. In algebra 2, dividing by 0 makes a vertical asymptote. Are those words that our brain says maybe? All right, dividing by 0 is bad. If we divide by 0, we get undefined or does not exist. Doesn't really make that much difference. I'll just go with undefined. Good enough. If you wrote does not exist, that it doesn't really matter. And now let's figure out the cosecant, secant, and cotangent. Let's speed it up a little bit. The cosecant is the upside down of sine. It used to be 5 over 5. Now it's 5 over 5. So what is it? 1 still. Okay, that's kind of nice. The secant, cosine is 0 over 5, but we got to flip that upside down, make it 5 over 0. And this one's going to be undefined. I'm just going to go with U in D. Probably good enough. And then the cotangent used to be 5 over 0. Now it's going to be 0 over 5. The cotangent is going to be 0. Donut. All right. So here's what's kind of happened. We have our, let me erase this just so I can make a little bit of room here. We know all about this. 0 degrees, 90, 180, 270, 360. We know about if we end up in quadrant 1, and quadrant 2, and quadrant 3, and quadrant 4. But what happened is we ended up not in any of the quadrants. We ended up right on the line. We ended up right between them. Now, I like to think about this as the corners. But if we're drawing a circle, can a circle have any corners? No, circles don't have corners. So they have a very fancy name. It is called quadrangles, or sometimes even quadrantals, but we're gonna go with quadrangles, which is basically just the corners, okay? It's those perfect 0, 90, 180, 270. Now, when it comes to trying to figure out positives and negatives, in this direction, it's 5. We've gone up 5. And so we're basically going to be positive, nice and positive. But we will have to see, maybe in some other questions, maybe we will introduce some negatives. Now, if you're thinking right now, Mr. Collier, I've had my ears open and I've been writing down, but the knowledge has not entered my brain yet. You're okay. You're okay. Let's do another question. So what if the terminal side of theta passes through negative 10, comma 0? Negative 10, comma 0. Is that moving me right or left or up or down? That's a left 10. And how much am I going up and down? Nothing. So I ended up right in my corner. Again, you can't really have corners of a circle, so we call it a quadrangle, which is just a ridiculous math word, but whatever. For this triangle, again, it's not a triangle, but we can envision it for a second as a triangle. How much did we go out to the side? 10. How much did we go up? 0. And that's why this is not actually a real triangle, it's just a line. But the triangle still helps us with our trig functions. And then what is the hypotenuse or the radius? 10. Okay. Now, for this question, this is not really a triangle, right? And we talk about how when you do these questions, when you do triangles, all the sides of your triangles are going to be positive distances because you can't have a negative distance. But this is not really a triangle. So we are going to count this 10 as a negative 10. The radius is always positive because the radius is how far you are from the middle. It's always going to be positive. But the x value here is negative. If our triangle, which is not a triangle, went this way, it would be a positive because we would go in the positive direction. But going this direction, we have gone negative 10. It literally says negative 10. So here's our triangle, which is not really a triangle. Determine the value of r. That's easy. What is the value of theta? Where are we? We're at 180 degrees, right on the corner, which is really a quadrangle, whatever. Okay, so what is the sine, cosine, tangent, cosecant, secant, and cotangent? Okay, so if we look at this, opposite is 0, adjacent is -10, hypotenuse is +10. The sine, does anybody feel confident enough to tell me what the sine of theta would be? 0. Or 0 over 10, just a 0. Where do we want to go next? Do we want to go to cosine or do we want to go to cosecant? Cosecant. Okay, cosecant, flip that upside down. The zero's in the top, the zero's in the bottom. Ah! We don't like zeros in the bottom. So what do we get? Undefined. Okay, now let's go to cosecant. Cosecant, or we just say cosecant. Cosine. Cosine is adjacent hypotenuse. It's -10, +10, which is -1. The secant is -1 upside down. Still -1.
Yeah.
The tangent is opposite adjacent, which is going to be 0 over 10 opposite over adjacent. And the cotangent is going to be A over O, and that's going to be undefined again. Okay, now, hopefully when we did this one, it felt just a little bit better. Maybe not way better. Maybe not this is easy, but maybe just, now before you flip, or maybe you can flip, but look up here. Compare the last question with this question. There's 6 things. Is there any similarity between the last one and this one?
Yeah.
2 of them up here are 0, 0, 0. And down here, 2 of them are 0, 0, 0. 2 of them are undefined. 2 of them are undefined. 2 of them are 1. 2 of them are -1, but they're very similar. Are we getting any numbers besides that? No. If it's 5, then it's 2 5s and it just makes a 1. If it's 10, then it's 2 10s and it just makes a 1. So, now let's go over to the back. Now, therefore, for the blank angles, I'm just gonna put corner. You know what? I'm doing it. Who's gonna stop me? Mr. Joseph, bring it on. You know what I'm saying? Just kidding. I'm scared of him. The 6 trig functions remain constant regardless of the what? Radius. I don't care if the radius is 5. I don't care if the radius is 10. It's either going to be a 0 or a 1, maybe a -1, or an undefined. For determining the values of the quadrantals, so should we went to T quadrantals? That's fine. It is easiest to use a circle of radius 1. Because there's no real reason to do a circle of radius 10, because it's still going to give you those values of 1 anyway. So what we have here is a circle of radius 1, and this is useful to you. This thing is pretty nice. This thing is a circle right on the coordinate plane. It has your 1, 0, your 0, 1, your -1, 0, and your 0, -1. It also has it labeled 0, 90, 180, 270. Now, if we kind of think back just a little bit, okay? When we drew a triangle and your sine, which is opposite over hypotenuse, your sine had to do with the y, because your sine, remember this is the y value, you're up and down, and sine deals with opposites. So basically we have this thing where sine theta is affected by the y. The x is affected by the cosine, because for cosine we need the adjacent. So now, let's look at our thing here. We have these coordinates, 1, 0, or 0, 1. And those can help us figure this out. So the sine of 90, here's our 90. It's 0, 1. Our answer is either going to be a 0 or a 1. Sine deals with the y values because it deals with the opposite and the hypotenuse. So sine is caring about your y value. What is the sine of 90? It is 1. If it's a cosine question, it would be the x value. Of course, they haven't asked us for the cosine value. So let's go and let's do the cosecant question next. And the bell is just about to ring for lunch. The cosecant of 270 is down here. Here's 270. That's 0, -1. Cosecant is just like sine. So does it like the x number or the y number? So cosecant is like sine. It likes the y number. And then cosecant is upside down. Take that -1, flip it upside down. Still the same thing. -1. Secant of 180. So that's 180's right here. -1, 0. Secant is a cosine, buddy. And cosine likes x's. Go to lunch. -1. Okay, this Friday, no homework. Here's what I want to think about. Like we said, we got our nice circle, and this is called the unit circle. It has a radius of 1. So a lot of times we will call this, or every time, we will call this 1, 0, because it's to the right 1, up and down 0. This one right here is 0, 1, because it's right and left 0, up 1. Then we got -1, 0, and then we got 0, -1. And we basically might as well just use 1, because if it's a 10, it's going to end up being a 10 over 10, which is going to simplify to a 1. So we might as well just use a 1 anyway. This, zeros and ones, okay, cool. The other thing we saw was undefined, and undefined shows up anytime you need to divide by that 0. So that's when that undefined comes into play. The last thing we want to keep track of, there's sine, or let's not use x, let's use theta. There's sine and there's cosine. One of these uses x values, one of these uses y values. Now, if this is still just not quite connecting in your head and it seems like I'm just making stuff up when I'm bringing these numbers, let me ask you this question. In what quadrants would sine be positive? 1 and 2, right? So this is sine positive, this is sine positive, and so down here, sine is negative and sine is negative. So looking at this, does it look like sine is affected by the x values, or does it look like sine is affected by the y values? The y values, because when it's up here in the positive y values, it's positive. And when it's down here in the negative y values, it's negative. So, that is why sine is the function that is dealt with, deals with the y. The cosine is positive in 1 and 4, a smart trig class. It's positive, so it's affected by the x values. Positive x over here and negative x over here. There's a couple different ways to get there. The last final spot is you can just memorize it, right? Sine is working with the y. Cosine is working with the x. Okay, let's go back. Let's finish up a couple questions here. Right before we left, we talked about that, -1. Let's do tan and cotangent. Sine and cosine deals with y's, deals with x, blah, 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 whatever, who cares. Tangent and cotangent are not cotangent.
Use the R.
Not exactly.
Mm.
Tangent is opposite over adjacent, and so tangent deals with both the x value and the y value. Here's your x value, here's your y value, and tangent needs both. The reason sine only needs one is because sine is opposite hypotenuse, and so, you know, the hypotenuse we don't really care about. So tangent is like the combination of both of them together. So let's do tangent of 180. Tangent of 180. Well, here's 180. Now back to right and white. So this tangent of 180 is -1 comma 0. Tangent is going to be kind of both those put together. Tangent is going to be opposite over adjacent when it comes to sine and cosine. Which one of these is the opposite function? Does the sine work with opposites or does cosine work with opposites? Sine works with opposites. So when it's tangent, it's actually kind of like the sine over the cosine. Because it's tangent opposite over adjacent. O is used in the sine function and A is used in the cosine function. So for tangent, we're going to do y over x. The sine over.
You got the bathroom pass?
Yeah, sure.
You got both of them?
So these are my bathroom passes.
Okay, where is that?
I don't know where his passes are. I don't know if he's got them locked up in the closet or something. You can borrow those now. Let's bring them back. So the tangent is gonna be y over x, which in this case is gonna be 0 over -1, which in this case is gonna be 0. That was for the tangent, not the cotangent. I kind of ran out of room there. Now, this tangent equals y over x. Thinking to yourself, oh my gosh, Mr. Collier, maybe the sine and cosine stuff was doing okay, but this tangent stuff seems random. Yesterday, on the top of the notes, if you've got a binder or something, we literally already wrote down on the top of those notes that tangent equals y over x. Something we already talked about. Just coming back a little bit. Okay. Let's see if we can power through a couple more of these. Then we're done. The cosine of -90. All right, they're getting smart. They're trying to hit us with the -90. I don't like negative numbers. How can we turn that number into a positive number? Add 360. -90 plus 360 is 270. So really, cosine of 270. There we go. -90 plus 360. 270. Great. Now, 270 is down here in this position, which is 0x -1y. So we're going to be working with 0 comma -1. And cosine, is that the x value or the y value? It's the x value. Cool. So the answer, 0. There you go. Not really all that crazy, but it is a couple things to juggle at once. Importantly, that the sine is the y value and the cosine is the x value. Okay, let's go over here and do the secant, -540. Now they're really trying to be smart. -540, we're gonna have to add 360. It's gonna tell us -90, and that's still negative. Add another 360, and it's the same thing. It's gonna be the secant of 270. Okay, and the secant of 270, we're right back here. Now, we know what secant is, but it's not sine, it's not cosine. Is secant buddies with sine or buddies with cosine? Buddies with cosine is the upside down cosine. So if we just figure out what the cosine is, flip it upside down, which will be all right. The cosine is the x value, so I'm thinking that the cosine 270, we just did it right here, is 0. The secant of 270, undefined, because we flipped that 0 down into the denominator. All right. I'm gonna power through these 3 questions here, and that's gonna be the end of us doing it all together. I got a little bit of an assignment. It's 6 questions or something. That's what we're gonna do for the rest of class, because there's still a little bit of time left. Let's do these. The tangent of negative 90, gross, add 360. I guess they're getting bored and they keep coming with the same thing. That's gonna be the tangent of 270. Sure, 270, again, we've used this like 3 times in a row. 0, negative 1. And the tangent is the opposite over the adjacent, which is like the sine over the cosine, which will be the y over the x. Negative 1 over 0 doesn't work. Undefined. The cotangent, I'm moving on already. Negative 360, gross, add 360, that's easy to do. That's gonna be the cotangent of 0. Okay, 0 degrees is over here. We can just call that 1, 0. Might as well just call it 1, 0. Cotangent is the upside down of tangent. Tangent would be y over x. Cotangent, flip it upside down, x over y. 1 over 0, undefined. And then we get to the secant of 540. Too high, subtract it. What do we get? Secant of 180. 180 is over here. That is negative 1, 0. Maybe I'll just write it right here. Secant is cosines, buddy. And cosine is x. So I'm going to take the x value, flip it upside down. What is negative 1 upside down? Negative 1. The secant of 180, here is 180, negative 1, 0. Secant is related to cosine, and cosine is the x. I take the x value, and I flip it upside down. No, so I'm just taking this, just the negative 1. Right? Only tangent and cotangent is when we build a complicated fraction. If it's cosine, you just take x, done. If it's sine, you just take the y, done.
So what would cosine be?
The cosine of this one?
Yeah.
Negative 1.
Okay. So
Look, here. $180 degrees. What was the cosine? What was the secant? Right? There we go. We did this question already.
all right.
Okay.
Let's do it.
We're at the point now where if I keep kind of doing it myself,